If you're a ready mix producer and you've been trying to figure out how to actually train your team, this is for you. We built the Concrete Supplier Playbook Foundations inside the Concrete Logic Academy specifically for producers that want their people to better understand the concrete they're selling and supporting. It's simple, on-demand training your team can work through at their own pace and start using right away. For podcast listeners, we quietly opened up a limited Founding 300 group. If you want to see what it's about, go to concretelogicpodcast.com/founding300.
What's the most used man-made material on Earth? I'll give you the answer. Concrete. This is the Concrete Logic Podcast. Have you ever stopped to think about the sidewalks, driveways, bridges, or the buildings around you? They're all made from concrete. So why don't we discuss it more? In each episode of Concrete Logic, we'll explore a unique concrete-related topic with the help of industry professionals shaping the trade's future. We'll talk with suppliers, contractors, architects, engineers, specialists, and even proponents of competing materials. We'll get their views on concrete and their visions for its future. So get ready to mix things up with Concrete Logic, where we turn the spotlight on the material that's everywhere but often overlooked. This is the Concrete Logic Podcast. And now, here's your host, Seth Tandit.
And welcome to another episode of the Concrete Logic Podcast. And today, I'm happy to have Chad White with SSI. He's back with us. You might remember him from episode 106, where we talked about best practices for placing and finishing concrete floors. Chad's been in the concrete industry for over 40 years. He started off as a cement mason apprentice to running his own company, and now he's a senior concrete consultant with SSI. He's worked on defined traffic superflats, high tolerance random traffic floors, suspended slabs, and more. He's an ACI member and longtime World of Concrete speaker. Today, we're going to talk about the evolution of the means and methods behind producing superflat floors. If you know, we're going to revisit FF, FL, and FMIN requirements. That's a lot of Fs. They're with all the automation that we're seeing these days, these requirements are getting tighter. So we're going to get into that today. But before we get started, just want to remind everyone how you can support the show. If you go to concretelogicpodcast.com, there's a couple things you can do for me. Well, I'm jumping ahead. First thing is, if you enjoy this episode or any other of the episodes, you learn something, please share it with a colleague or a coworker. Second thing is going back to that website, www.concretelogicpodcast.com. There's a couple ways that you can get a hold of me. And I actually changed something on the website. If you look at the top now on the menu, it says on the menu, it says Ask Seth. Click on Ask Seth, and on that, you can fill out, it's like sending me an email, fill out that form and tell me what you want to hear or who you want to hear from, something you want to learn about. That's what that's for. Also, if you're more of a verbal person like myself, sometimes I struggle to write. There's a microphone in the bottom right-hand corner on the website. You can click on that, and that's like leaving me a voicemail. Do the same thing. You can tell me what you want to hear, what you want to learn about. This podcast is for you. And then the other thing you can do to help support the show is make a donation. There's a donate button in the upper right-hand corner. So if you click on that donate button, you can give any amount, and any amount is appreciated. And today, I want to thank Scott Reed with Prolog from Richmond, Virginia. Scott Reed. This is going to be a perfect episode for you to support, actually. Scott introduced me to 3D scanning. It's got to be at least a decade ago, and this was before 3D scanning was really a thing. Helped me out on a project that I was doing in Richmond. So Scott's a great guy. Thank you, Scott, for supporting the show. Also, another way you can support the show, if you enjoy the content on here, make sure you check out the Concrete Logic Academy. There's, again, if you're on the podcast website, there's a link to that. But it's the same kind of content, but we're going to quiz you, make sure you understand what we're talking about. And then there's some other functions within the academy the platform. So, all right. With that, Chad, let's get back into it. So we're going to talk about kind of the evolution of super flat floors. But I guess just to get you warmed up for today, let's talk about when you first got started. What was a high tolerance floor like back then?
Gosh, I started in the business in 1974. At that time, the only way we really tested floor flatness was the 10-foot straight edge. A Class A finish was an eighth in 10, which basically meant when you set the straight edge down on the floor, if there was any gaps under the straight edge that was greater than an eighth, that would not be a Class A floor. And if you start thinking it through, putting a straight edge on a slab in random locations is pretty subjective. So we really did not know what we were getting on the floor. And you got to remember, this was before laser screeds. This was before float pans. When we first started working on Superflats, we really had no idea what we were doing. It was almost like it was a magical thing. I mean, how do we get these numbers? So with a lot of trial and error through the years, we came up with a system. And really, the first thing we start talking about super flats is, then that term is thrown around a lot in the industry. Yeah, we're doing super flat floor, this and that. But what's it actually mean? An actual super flat on an F-min, which is a defined path, is F-min 100. So technically, if you're doing an F-min 60, it's not a super flat, but we call them all super flats. And then on a random traffic floor, a super flat is considered anything that's an FL40 or above, which with today's laser screeds and pans and trowel machines, just about everybody can pour a super flat. So for what I consider a super flat for a random traffic would be when those numbers start getting up there. When we're talking an FF, that's a super flat, because to me, the differentiator is when you're doing super flat, you have to do more work to that slab surface than you would do just replacing a conventional slab. A little bit of the history on super flats, they first came into being in the 70s, and it was driven by narrow aisle, high bay racking system. And what they had, the tow motor, the forklift, whatever you want to call it, they would cut a saw cut in the slab. They would put a wire, and that's what guides it. And then what brought about the tolerance issues was you've got warehousing, racking that's now, instead of the 35, 40 feet high, you're going 60, 80, up to 100 feet tall. So think about it. If you've got a forklift that's got a footprint of 6 foot, it's booming up in the air 80 feet. If you're out a quarter inch, what's that doing to your mast up there? So if the floor is not at a flat enough, you're not going to be able to safely pick your stuff up there.
It's been a long time since I've done trigonometry, but I don't know how far you'd be out.
You'd be out quite a bit. But so that's what started driving it. And it was the warehousing logistics industry, they needed to get flatter floors so they can go higher. And then on your high tolerance, super flat random traffic, initially about the only demand for it was like television studios or movie making, to where they're rolling a camera along. Well, if you've got a wavy or bumpy surface, you're going to see that in the filming that it's doing. So the first high tolerance super flats for random traffic were usually TV studios. But now we're seeing robotics. Robotics is pushing a lot of the high tolerance random traffic super flats, because the robots have to travel everywhere in a random path. And if the floor's not flat, they have issues with, maintaining their load and moving and everything. So that has become a lot of it. The other for random traffic that's would be ice rinks, roller skating rinks, gymnasium floors, stuff like that. Plus, it's the nature of the beast. For years and years, a conventional slab of 35-25 was about as good as we could do on a day-to-day basis. Well, as they've improved the laser screeds and the pan floats, now my expectation if I walk out onto a conventional job and they're using a laser screed and they're using pans, you're going to hit a 60-40 just doing normal stuff.
And how are we measuring that? Let's talk a little bit about how we're measuring these
Sure.
numbers that you're sharing.
An F-min floor, which is what they call a defined traffic, that's measured with a profilograph. And what that does, that profilograph is set up where it's set up on the wheelbase of the truck motor that's going to be used. And then it rolls along on the truck motors are going to run on the same path all the time. They don't deviate at all. So they run this profilograph along and it actually records exactly the waviness of the floor, what highs, lows. And it's actually, it pops out a printed graph to where you can go back and you can exactly identify where you've got a high spot or a low spot and needs to be corrected. Unfortunately, that's always done after the work is done. So it's corrective grinding to get it in tolerance from that standpoint. But future, I think we're going to see some changes on that. Then on high tolerance random traffic slabs, they use a profiler. Your typical ones are a dipstick, an axiom, a D meter, an F meter. And these are basically, they give you a point to point, let you know what the variation is over 1 foot. And as you know, an FL is your measurements over 10 foot, how much deviation. And your FF is over 1 foot, how much waviness. So you can have a floor that is level, but the surface is bumpy. So the FL may be very high, but the FF will be low. Then you can also have a floor that's tilted, so it's not level, but it can be perfectly flat, so you could have very high FF numbers. So those are the tools that are used. And a little history, like I said, we started in the 70s. I'm looking at my notes here a little bit. The F number system, which was developed by face companies, was first used in 1983. That's if you really think about it, it's not that long ago.
No, not at all.
50 years.
At least for some of us.
Yeah. The ACI standardized F number system was officially, per ACI 317, was 1990. So we did not get rid of the 10-foot, straight edge method, gap method, officially until 1990.
I've had people on here on the podcast that wanted to bring the straight edge back.
Good Lord, I don't know why. I mean, back when I was a finisher foreman working in the field, you could get with a client and they could go and check a floor, and I guarantee you, I can find a bad spot in any floor, that will not make the 8th and 10. Actually, to make a true 8th and 10, you're probably looking at FF numbers of 75 or 80 and FLs of 50 or above. Just a little history that my personal knowledge, I've went back and surveyed I went back when I was a contractor and I had 10 slabs that had tested, all of them above an FF60, FL40. So I wanted to find out, okay, well, what's the envelope for that slab? And we measured 10 slabs that we had done that we knew were 60-40 or above. And the average envelope was 3/4 of an inch from the high to the low on that slab placement. Yeah. So we're not as flat as we think we are. Laser scanning is beginning to show us a lot of that, we're not as flat as we thought we were.
Yeah, that's what I was going to ask you is are we getting better at measuring or are we getting better at finishing?
Well, if we do one, the other follows. If we get better at measuring, the more data we have, the more we can improve.
Yeah.
Kind of getting off track here, but I read an article. There's a contractor in Japan, and I don't have the article. I wish, because I'd love to credit them. They were doing a ice skating racing oval, and it had to be extremely flat. They combination of using a truss screed with laser sensors on it set up every 2.5 feet and real time laser scanning of the floor to where they literally had a projector mounted up on a crane to where they could scan that floor and then they would show in a different color anything that was out of tolerance,
Well, that's cool.
to where they could literally go out there and scrape it or fill it. They ended up doing that and they got that within 2 millimeters, the
Wow.
envelope on that slab.
It projected the color on there or did they look on a screen?
No, it projected the color on the slab.
Oh,
I'll send
yeah.
the article to you if I can find it. It was amazing. Now, what did it cost to do this? It was probably very expensive,
Yeah.
but the
Somebody paid for it.
capability is there. Yeah.
Yeah.
To where, if you can get a slab 2 millimeters, the envelope from high to low, that's just phenomenal to me.
Yeah.
That you can do that. But getting on the other things, the other high tolerance random traffic is your automated rack storage and retrieval systems that you're seeing being built now. And most of those, there is no forklifts running in the aisles. All the retrieving, it's up on runs right off the racking. But they want those floors to be as flat as they possibly can because they're maybe going 120 feet in the air and they don't want to shim anything, or keep the shimming to a minimum because the more you have to shim racks, the less stable they are. So you're seeing a big push. Robotics is pushing more flatness in the floors, and these automated storage and retrieval systems are requiring the floors to be much flatter. Now, talking about some of our legacy ways of how we did a super flat back in the day, which some of it hasn't changed a lot, but let me walk you through a typical F-Min 1985. We tried to, I worked with Baker at one time. I worked with Jesco, I worked with Calvin, different people, but everyone's pretty much the same. The form work, you had to get the form work exact because the only way that you could strike off the concrete was with a truss type screed, which went from point to point. So even though your construction joints are under the racks and don't have to be flat, you had to get them exact so that the rest of your floor could be exact. So, and there was a lot of different things. People tried using bar stock attached to a wood form, and then you adjust it up and down and this and that. And it worked, but it was hard to keep it uniform over 300 feet or whatever.
Yeah. Was there a maximum width to your lane that you could do at a time?
Yeah, typically at that time, everything was one aisle. We did one aisle at a time. So in order to get under the racks, you were anywhere from 11 feet to 14 foot wide. So, you're pouring strips that are 200, 300 feet long. And I would say if I had to give you a typical, it'd be like 12 feet wide. So you're setting up all these strips. And we would use wood forms. And this is when we first started beveling forms, to where you cut the top on an angle so that you're just finishing to a point. That's when we first started doing it. And we'd set up a jig, and you'd always cut the grain. A piece of wood has a grain in it like this. Well, you always wanted to tilt it to make certain that you're cutting the top of the grain so that the form would relax. So if you cut the other way, it's just going to warp. So we would cut all our forms on a jig. Then you would set them up, stake them securely, at your joints on your form work. Then we would take a 12-foot straight edge and we would go down, and at every joint in the forms, we would slide that across the top of it. Well, if it was high in any spot, that would leave a black mark. So then we would take a hand planer, a power planer, and literally plane the surface of it to try to get that form as level as we could all the way down. Very exacting, very exacting.
So
Go ahead.
Can you compare that to what we do now? What do we do now?
Biggest difference we're doing now is we've learned to use laser screeds to do superflats. So the screed, because we're doing all this work on the forms, which doesn't mean only thing what's going to get measured is 4 foot wide in the middle of that 12 foot. But we had to have the forms perfect because of the way we had to strike it off. Now we're using laser screeds, which is a wet screeding process. It doesn't matter what the forms are. So now when we go in to set up a F-min job, we'll use laser screeds on each side. And it doesn't matter what the forms are. I mean, you still got to be within 1/8 of an inch, but that has no bearing on what your tolerances are in your aisle. So it saved a lot of work on the form work, a lot of work. So now we got the forms all set, and there's various reinforcing systems. I'm not going to get into all that because we're just talking about means and methods here, but most of these slabs, F-min slabs, are not sawn. They're designed to crack wherever they'll crack, so they're heavily reinforced with either fibers or reinforcing or post-tensioning. Back when we first started, a lot of them were post-tensioned. So you'll see various reinforcing strategies. But, okay, we got the form set. Now we're going to pour concrete. And the difference with a super flat is you take everything one step further. Like when we're pouring conventional slabs, I like to see the slumps on the trucks. No more from a truck to truck or over the course of the placement do I want to see more than a 2-inch variance. So if you're trying to pour at a 5, if you can keep everything between a 4 and a 6, that's pretty good. On a super flat, we were looking for 1-inch variance in slump. I don't want, if we're trying to pour at a 5, I'll pour a 6, but I'm not going to pour a 4 right behind it. I might pour a 5. So every truck, we tried truck to truck to keep everything, and you end up rejecting a lot of concrete. And it slows you down. You're testing a lot more. I've had a lot of super flats to where when we first start pouring them, we're slumping every truck on a 300, and you're not pouring 1,000 yards of super flat at a time. You're pouring 250, 300 yards, but we're slumping every truck. And if it doesn't hit those parameters, we're rejecting it or tempering it or whatever. So productivity levels go down. You need a lot more people. The most common method back then, and still is, for doing narrow aisle placements is using a vibratory truss screed for your initial strike off. So we'd place our concrete, crank up the truss screed, and bring it down. And then while we're doing this, you've got 2 carpenters on each side checking the forms as the concrete is placed using wedges to make certain everything is dead on. And we shoot everything with an optical. You don't use a laser with high tolerance. There's just too much variance in the band. So our recommendation is always use an optical, builder's level to shoot everything in so you know exactly how much you're high or low. And then after you strike it off, then we would use a typically a 2x5, a big heavy magnesium or aluminum straight edge, longer than the width of the pour. And we would run that behind the truss screed, and you used it in a seesawing motion to where you're sawing the top to where you're trying to get all of that excess off and get it down just as tight as you can get it. Very labor intensive. And guys that did that on a regular basis had arms about like that, from doing that all the time. So now you've got it, finally you've got it struck off. Well, then you would start your bump cutting, which a bump cutter is basically the simplest way. It's a straight edge with a handle. Our bump cutters and check rods, they came from highway work originally. That's where your check rods, they would run those behind pavers, why they were called a check rod. And that a check rod's when you lay the straight edge flat. A bump cutter's when you raise it, put it up vertical. So like in the paving operation, they would run a check rod out and then pull it back and see if there's any highs or lows. Then you could use a bump cutter to scrape the floor. So you would scrape the floor, and that's a two-man operation. One guy is pushing the bump cutter to straight edge out, which is basically a bull float handles and a hustler type head, or, pushing it out. And then he would make his first cut to where he's holding it straight up or even cocked backwards to where he's dragging that back. So that will show any low spots because you'll see the light under it, and any high spots, you're going to cut them off, which if it's too far out, you're cutting into aggregate. And as he pulls that to the side, well, that slurry, that paste, second guy has got a shovel. And as he pushes it back out, he throws that out to fill the low spots. Then you'll bring it over it again. A typical super flat, you would bump cut it at least 3 times, oftentimes 4 or 5, once or twice before you started your float operations. And we always used walk behinds. Back then, we didn't have the nice double trowels like we do now. So we used walk behind trowels with float shoes on them. And when you do your machining on an F-min floor, you don't, it's typical to machine the first time in the opposite direction of the straight edge, and then each time you go in an opposite direction to keep it flat. Well, doing an F-min, you don't do that. You run everything long ways. You don't cross anything up. Because I don't care if the whole slab's flat. I just want that aisle where those wheel tracks are. That's what has to be flat. So I'm machining everything in one direction all the time. And that goes from my floating operations to my troweling operations all the way through. I never turn the machine the other direction. Everything runs to one direction. And then what we would do after we had pan floated, we would take a straight edge. Straight edges are hollow. I don't know if you know that. They got end caps in them.
Mm-hmm.
Well, we would take 4 or 5 number 5 rebar, put them inside the straight edge to where that straight edge weighed about 50 pounds. And that would be our last pass over the floor, would be with a bump cutter, a 50-pound bump cutter, pulling it across to scrape that last little bit. Then we would finish it like you would finish a normal slab. Do you want a semi-glossy hard trowel finish? So now you're done. So then they come in and testing agency with your Profilograph, which is set up. It's got wheels on it. It's set in the way the truck motor is. They'll set a string line to where it shows the center of the aisle. They position the machine. Then they'll run the machine down to test you. And as they're running the test, like say it's got a little graph that's actually printing out. They'll make the run, pull it through, and they've got a band on there of what. So everything ideally stays within that band. Anything that's out of the band has to be corrected. And typically on an F-min job, you're allowed corrective grinding for 5% of the aisle length. So if you poured 100 foot of aisle you can correctively grind 5 foot of the aisle and still be within specification. We always shot for 3% ourselves. And yes, can you do an F-Min 100 super flat and no grind? Yes, it happens. But I don't know of any job where they've done multiple pours or placements where they did not do any grinding. The best
Mhm.
floors I've ever done, we had to do some corrective grinding on. So then, like I say, he's got the graph, he's identified the areas, then they'll go back and mark them. Between this point and this point, you're out 3 mils, you're out 6 mils or whatever. And then you're allowed to correctively grind in that area to get your floor. And the biggest problem with super flats is the same with all concrete. Just because you measured it and ground it on day 1 through day 7, there's no guarantee at day 365 that floor is still the same.
Yeah.
The floor moves, it curls. So that's where your different reinforcing strategies came in, to try to mitigate the shrinkage and curl on a slab. But unfortunately, we haven't been able to get through that all the way.
What time frame do you usually see where you do a corrective action like a grind?
Typically, when we're doing this, you want to do the grinding before the slab's cured, before the slab's too damn hard, and because that's about all you can ask of a concrete contractor. I put it in per your specifications. What it is 6 months from now, that's something else that's going to have to be dealt with. I can't control that part of it. So yeah. And that's why you're seeing a lot today. There's a lot of, in the United States, everything is spec warehousing. So they may have a warehouse that, is built to 5035 standards, and they want to come in and do a narrow aisle, high bay thing. So they'll come in and do corrective grinding over the whole floor, every aisle, you know. So that can get very expensive. Then when it came to high tolerance random traffic floors, initially when we first started out, it kept the placements very narrow. Anything that you could reach from one side or the other with your bump cutters, that was what the limiting factor. So you very seldom got over a half a bay wide because you could not reach it with a manual bump cutter and do it effectively without getting out on the floor. What we would do is, the same tolerances on slump, temperature, set, and then we would extensively bump, at the beginning, we were still using truss screeds. Laser screeds didn't really come around to like 1986, I think, 85, 86. I actually looked it up as to when, I think, 86, yeah.
Okay.
So before that, we were using truss screeds. Then we would just bump cut it, bump cut it, bump cut it, and that's where we was at. So super flats are very labor intensive, even to this day. It's not as much as it was, but they're still very labor intensive. And you still have the conundrum that, we're going to place it to these specifications today, but 6 months from now, it may not be there. But this is the best we can do right now. Trying to think, that was really about it back in the day. Now, though, we're seeing some innovation in the market. And the two biggest innovations that have probably increased our ability to get flat floors, number one is the laser screed. When they came out in 86, that opened up to where now we could do high tolerance random traffic slabs that were 50 feet wide, that were 100 feet wide, that were 150 feet wide, because, it was all wet screeding. And the initial laser screeds that came out, they were good, but they were nothing like they are now. Back in the day, and it makes me sound old when I say back in the day, but when the laser screeds first came out, we could hit the 50-35 numbers pretty consistently, but we had to bump cut it one time. Now, as I said earlier, my expectation is a 60-40 and not doing anything other than normal conventional finishing. And the big difference is the laser screeds. Laser screeds have gotten so much better. The hydraulics, the laser systems, they can really get you a flat floor. And the second innovation that has really changed our industry is float pans. And I believe Allen Engineering was the originator of the float pans, and that was in 1989. So it hasn't been, that's 35 years ago. But that increased our FF numbers from using float shoes tremendously, tremendously. So those are the two big things that have changed how we approach high tolerance super flat floors. And then since that time, we've had a couple of other things that are coming on the market that have really helped the bump cutting. Like I said, manual bump cutting is very labor intensive. There's a safety issue to it. There's a lot of back strains, a lot of hemorrhoids, because you're pulling, jerking, and it's bad on your body. It's just bad on your body. So over the last 15, 20 years, people have experimented with different bump cutting attachments that are either mounted on a troweling machine or pulled behind a troweling machine. And we've got that, they've improved that quite a bit to where, we can now probably using a bump cutter attachment on a pan machine, we can increase the FF numbers probably about 20-25%.
Oh, wow.
Yeah, it's
just dragging it behind the machine.
It's caveman technology. It's doing the same thing as a manual bump cutter, but where I was talking earlier that maybe we would bump cut manually 3 times, very labor intensive. Now using a screed sled, a bump cutter attachment behind your trowel machine, you're bump cutting the floor 10, 15 times. Machine don't get tired, unless it runs out of fuel, it'll keep going. So that's really improved that aspect of it.
Yeah.
Another thing we're seeing is flat pan. We're seeing dedicated panning machines. You're seeing several of the large manufacturers have come out with dedicated pan machines. And then you're also seeing aftermarket where you can change the arms out to where they spread that weight of the trowel machine more equally on the float pans. So you have greater contact with the floor with the float pan. So we're getting flatter floors using those systems. I think, and don't quote me on it, but I think they say a typical pan with the trowel arms, you've got about a 40% contact with the slab surface of the pan, to where when you use the one I can think of offhand is the Bigfoot pan saver system. They spread that out and they say they're getting about 70% contact. So the more contact you get, the flatter the floor is. Laser screeds, we've learned to use them much better. We've found that we had talked earlier about we would strike it off with a truss screed and then run the seesaw behind it. Now what I'm seeing when we do super flats, we will double strike or even strike the slab 3 times with the laser screed head to get the floor flatter. And we've also learned the big thing on the F-mins that's really done some cost saving and allow us to make larger placements is we're using 2 laser screeds, one on each side of the pour, and they're booming out. Like say, we're pouring an F-min when I was talking earlier, 12 to 15 feet. Now we're pouring up to 35 feet wide, and we're pouring 2 to 4 aisles at a time. Using the screed on each side, they're booming out to the center and screeding the slab back on each side.
Yeah.
and we'll have them screed it 3 times. They'll go back, screed it again. What I like to see them, what I tell them is, the auger on a laser screed is what is doing your strike off. So I tell the guys when I'm training and working with them that I want you to screed that floor to where I see nothing coming off that auger. I don't want anything coming off of it. We've got that floor as flat as we can now. And with the better laser screeds, the better hydraulics we have now, we're getting some really good numbers. And now the edge forms, it doesn't matter, because they're not dictating the elevation of the floor. So we don't have to be as critical, don't have to spend as much time on the form work. So there's a cost savings there. Plus we can go wider. So that has been a huge benefit.
What about design as far as the concrete itself? Are we getting better at that? Is that making it easier as well?
Well, concrete has always been a compromise. So it can do a lot of different things. If you do this to bump cut a floor as much, the straightening and restraightening of a slab surface, you got to have paste. So how do you get paste? You got to have cement. So you raise the cement. So what happens when you raise the cement? You've increased the shrinkage potential of the floor. You've increased the possibilities of delamination or peeling or whatever. So you have to design a mix that, it's kind of, you don't make everybody happy. You don't hit all of them, but you try to do the best you can. So, you got to have enough paste to where you can finish the floor after you've scraped it numerous times. You've got to have bleed water. You've got to, as an old finisher, back in the day, we fought excessive bleed water. And most of that was because we had gap graded aggregates in our concrete. So you had all the channels for the water to go up. Now we've optimized the aggregates so much better, where we've got a much more cohesive blend of concrete. But it comes down to, it's not exotic mix designs, it's the discipline to execute the same truck to truck to truck to truck.
Yeah.
Getting the slump. That the biggest thing is the consistency of the slump and the rate of placement. Because every time I've seen grinding on a typical high tolerance floor, it's where you start and stop. It's off where you started this pour. And if you had to stop for some reason and start again, and then when you got to the end of the pour, if I had to pick some place to where that's where you're going to have issues. Those are where they're at. So you want to make a factory job out of it. It's very difficult to do high tolerance floors outside, unprotected in the elements. It can be done, and it is done on a daily basis, but it's difficult. As I've said, on any concrete, you want to control the variables and eliminate as many of them as you can. So ideally, when you're doing high tolerance floors, you want a controlled environment. You want the same weather every day. You want the same concrete every day. You want the same temperatures. You don't want variation. That way you can figure out what works, and you can do it consistently, repeatably every day. Yeah. So it's the execution. I've said it 1,000 times. It's attention to detail. Well, the details matter a lot more on a high tolerance slab.
Mm-hmm.
Going forward, the future, I think what you're going to see is laser scanning. We're going to have the more data and information you can furnish in real time, the better job you can do. And our ability to collect data is improving all the time. Laser scanning, we're starting to see some of it. They'll come out and they'll laser scan while you're pouring. Part of the problem is you can only do sections at a time, but we're going to get past that in some way to where you're going to be able to give information to those crew leaders on the job, hey, we're out of tolerance right there.
Mm-hmm.
And they can fix it in real time versus grinding it after the fact. So I think going forward, I can't think of any new or exotic technology that's on the horizon that's going to dramatically change how we do high tolerance floors. But I do think our ability to gather data in real time is what's going to push us forward. So you're going to be able to, if they can get data to you to where you can make corrections, now we're not confined by configurations of narrow aisles. We can make placements of various configurations and still get the same flatness. So, and I think that's what we're seeing coming in the future. So, and that's pretty much where we're at right now with high tolerance floors. The FMIN defined path, that's always going to be a little bit of a niche market. But the high tolerance random traffic floors, we're going to see an explosion in that. And robotics and the automated rack storage system is what's driving that.
Yeah.
Plus, we have the ability to do it without a tremendous additional cost. People are always going to want flatter floors. The flatter the floor is, the easier it is to work off of it.
Yeah, it gives the building more versatility in what it can be.
Exactly. Any other questions on?
No, I mean, I think you covered everything that we were thinking we were going to cover today.
Okay.
So I appreciate it. Always glad to have you on the show. If folks want to reach out to you or SSI, what's the best way?
Probably the best way is either at our website, ssi.com, or I can be reached at cwhite@ssiteam.com. And give us a call. We'd be happy to talk to you.
Yeah, and we'll have Chad's link in the show notes so you know how to get a hold of him. And if you, he'll have his own, he already has his own page since he's been on the podcast before. But if you go to the podcast website, Chad's got his own page so you can go and find his link there as well. All right, Chad, I appreciate you coming on the show today. Glad to catch up with you. Yes, sir.
Great.
And folks, until next time, let's keep it concrete.
Thanks for joining us for another episode of the Concrete Logic Podcast. If you got value from the show, here's how you can provide value back to support the show. Visit concretelogicpodcast.com and click the donate button to send value back. All dollar amounts are truly appreciated. And now, to close out the show, here's Mike Dunton.
That alarm always sings couple hours before the sun comes up. Open up the side, put some diesel in the lights and wait till the trucks roll up. Yeah, this ain't how most folks live their lives, dripping in sweat, working overtime. But while they're tying their ties for their 9 to 5s, we're